Today we're talking about points on a line. So these are your points on a line notes. So the first thing I want you to do is tell me anything you can about this line right here. So if you are watching this in video, please pause the movie and list as much as you can and then come back and see if we got the same things. So when I look at this line, the first thing I notice is it's rising from left to right. So if it's rising from left to right, you know that that has a positive slope. So positive slope. So what type of slope does it have? Let's count it. So let's do our rise over our run. So I see a good point here. I see another good point right there. So up 1 over 1. So 1 over 1, it has a slope of 1. So M stands for slope. What else can you tell me about it? I also see some key points here. I've got the y-intercept. Another way I could say that is the lowercase b, and that is at -3. I can see where it intersects that y-axis right there. And then I've got the x-intercept right here at +3. So x-intercept at 3. So knowing all that information, I guess the only other thing we can tell about that line is the equation of it. So thinking about slope-intercept form here, the equation of that line is y equals, my slope is 1, x plus my b, which is -3. So the simplest way to write that is just to write that Ninja 1 as just an x minus 3. So what does a point being on the line mean? So I've got 3 points for you. I've got 3 points marked for you. I've got -2, -5. I've got 0, -3, which you recognize as the y-intercept. See how we have a y value but no x value? And then I've got the point 4, 1. So what does it mean to be a point on that line? So yes, it's on the line. Yes, it's on a specific intersection there. But it also means that this equation is equal. So let me show you what I mean by that. So each one of these is an x and a y, right? So let's plug in that x and the y right into our equation. So y is equal to x minus 3. Let's try that out. So y is equal to x minus 3, but instead I'm going to put in my x and my y. So is -5 equal to -2 minus 3? Check that out again. I plugged in the x right here. I plugged in the y right here. And when I go and solve that, I do find that -5 is equal to -5. So that's true. It makes it true. Let's try it again. So we've got y is equal to x minus 3. That's the equation of the line. We got that from up here. And now all we have to do is plug in -3 and my 0. And is that one also true? And yes, -3 does equal -3. So when I do that subtraction there, I get -3. Let's try it one more time. Is this point also on the line? We can see it, but let's see why it is. When I see y equals x minus 3, I plug in my y, and I plug in my x, and 4 minus 3 is indeed 1, just like it said it should be. So being a point on the line means that it makes the equation of the line true. It makes it equal. So we're going to use that today to help us out. So here's another example. So I've got the equation of the line here. It's kind of off to the side. So make sure you know that this is y equals -2/3 x minus 1. Notice it starts here at -1, then goes down 2 over 3 to its next point. So what are some points along that line? Hopefully everyone noticed the -1. So that is our y-intercept, so 0, -1. And then I'm also going to pull out this point and this point down here. So the other good ones that you would do the slope with, right? Down 2 over 3 or up to backwards 3. So I've got, that's -3, 1. And then this one over here is 3, -3. So I want to try that out real quick and just check those. So if I plug in 0 and my x, so my x and my 0 is my x and my y is -1, do I get something that makes sense? So again, I'm going back to the equation of the line. I'm plugging it in. Is -2/3 times 0, which is 0, minus another one equal to 1. And yes, we found a good point. Let's try this one right here. I've got 1 should be equal to -2 over 3 times my x, my -3, minus another 1. Now this one's an interesting one. So when I am solving this one, I've got a negative times a negative, so I already know that's going to be a positive. And then I'm going to multiply by 3 and divide by 3, so those cancel out. So the only thing I really have sitting here is 2 minus 1. And 2 minus 1 is 1, just like we were looking for. Alright, let's check the last solution that we saw on here. And let's just see how this goes. So I've got, should be, negative 3, my y, should be equal to negative 2/3 times this 3 minus another 1. Again, we've got multiply and divide by 3, so that cancels. So I've really got negative 3 is equal to negative 2, right there, minus another one, which is true. It is equal to negative 3. So I've got 2 new problems for you. I'm going to erase all that work real quick so we have a fresh board. So those points that we pulled out and checked, we could see those points. But maybe we can see these, maybe we can't. So is 0, negative 2 on the line? So if you had the graph for it, just check it on the graph. 0, negative 2. Is that on the line? No, it isn't. Let's also check what that looks like in a formula so you know if it wasn't on the line and you couldn't see it, what it would look like. We've got an x, we've got a y. So I'm going to plug that in. Does my y, so my negative 2, I'm back to this equation right here, equal negative 2/3 times 0 minus 1. So when I'm going through, I don't know if that's true or not, so I put a question mark there. When I'm going through, I'm going to use PEMDAS. So I've got multiplication first, that's 0 minus 1, which is negative 1. See how what you get out isn't actually equal? So you know that's false, no, not on the line. But again, you could have also told that just by the picture because it's down here and our line's up there. So that one is not on the line. Well, now let's look at 9, negative 7. So let's see where that would be. 9 is off the grid, so is negative 7. So it's in the right quadrant. So right now, if I was eliminating with multiple choice, anything up here I'd eliminate. Right here I couldn't really eliminate unless it was way over here. And then over here I could eliminate everything as well. But this is in the right quadrant, so let's see if this is a point. So we've got x and y, and let's go back to our equation of the line. Y is equal to negative 2/3 x minus 1. I'm going to plug in my x, I'm going to plug in my y. So negative 7 is equal to negative 2/3 times my x, 9, minus 1. I'm going to give us some time to think about that fraction multiplication real quick. I'm going to erase all this up here. I'll get that out of the way. And now let's see what's happening here. So I want to know if this is actually equal to negative 7. So I'm right here, and I'm going to multiply by 9, or 9 over 1. Do you remember your bow tie cancellation, how you can cancel from the bottom to the top? And this is going to make 3 left over, so I divided both of those by 3. So what I really have right here is negative 2 times 3, which is negative 6, all over 1 times 1, which is just 1, so I don't need to write it. And then I'm just coming over here, I'm saying minus 1, and I see that negative 7 is equal to negative 6 minus 1. That is true, because that is negative 7. So you see how I get out that true phrase? So I know that yes, even though I couldn't see this one, this is on the line. So it was down here and it was in the right spot. So if that could continue, we would see it. All right, so this is how they do it on the SOL to you. It says circle all the points that are on the line. On the SOL, it would be one of those hotspot questions where you click to shade all the ones that were made it true. And my line just looks a little bit different. It's not in slope-intercept form, but that doesn't matter. When we plug in our x and our y, we're going to see if it equals 32 this time. So let's try it out. We've got 2 times our x minus 8 times our y. Does that equal 32? So I get 2 times 1, which is 2, minus 8 times 4, which is 32. So I'm using PEMDAS here. Now I get to subtract, and I get negative 30. So does negative 30 equal 32? And you would tell me no. So that one is not on the line. So all you have to do is like put a little x there. All right, for this next one, we're going to plug in 16 and 0. So my x is 16, so 2 times 16 minus 8 times 0 is equal to 32. So I've got 2 times 16, which is 32. I've got 8 times 0, which is 0. And is that equal to 32, like we said it should be? And yep, that is equal to 32. So this is a point, circle it. All right, next one. How about 0, 4? So we're going to plug in that x is 0 and that y is 4. And we're going to see if that's equal to 32. So 2 times 0 is 0, minus 8 times 4, which is 32. That's close. It's not quite equal to 32. It's equal to negative 32. But that is not equal. They're different sides of the number line there. So that is a no. Let's try the next two then. This one's very similar. I think this one's going to be it. We've got 2 times 0 minus 8 times negative 4. And that should be equal to 32 if it's a problem, if it's the right answer, the point on the line. So 2 times 0 is 0 minus 8 times negative 4 is negative 32. I see that double negative right there cancel out. So I really have 32 is equal to what we wanted it to be equal to, 32. So that one is a solution. All right, last one. Let's try it out. We've got an x, we've got a y. So I've got 2 times my x, which is 4, and then minus 8 times my y, which is negative 3. And is that equal to 32? So 2 times 4 is 8, minus 8 times negative 3 is negative 24. And that cancels out again to a positive 32, which is exactly what we were looking for. So 3 solutions there, 16, 0, 0, negative 4, and 4, negative 3. So all of those are along the line that we saw there. All right, on the back of your notes, got 2 more problems. I know this one's not quite a line, but we can tell a lot from it. First off, I want to know how many people were in the store at 11 a.m. So when you start this, first we want to read the title, People in a Store. And on the side axis here, our y-axis tells us the number of people. On our x-axis here, it's telling us the time. So if I'm looking at 11 a.m., I want to look at my time axis. At 11 a.m., let's see where my line is. It's at 5. So I had 5 people in the store at 11 a.m. So for my next question, at what times were there 4 or 5 people in the store? So I'd be happy with 5 people, or I'd be happy with 4 people. So I've picked out all of those. And so there were 4 times. They were 11 a.m., they were 3 p.m., 4 p.m., and 5 p.m. If you're confused about where I'm getting those times from, look down below. I was just lining it up with what time it was on the graph at what level it was on the y-axis. So if I wanted in between 5 and 4, I just looked for those 2 levels on the graph. All right, my graph's getting a little messy, so let me erase that so we can see it fresh again. It says, when was the store the busiest? So the busiest would have the most people in it. So I need it the highest on my number of people, which would have been 22 people at 1 p.m. What is the difference between the amount of people in the store at 12 p.m. and 2 p.m.? So let's look at those two. 12 p.m. is 10, and the other one is 2 p.m. right here at 15. So difference means subtract. So I have big number minus small number. The difference is 5 people. So 5 people, but let's make that more complete sentence there. So there were 5 more people in the store at 2 p.m. So busier at 2 p.m. So when you see a graph like that, and if you were a person that was managing the store, you'd see you probably don't need as many people working, after 3 and on, or you probably don't need most of your people to show up till maybe 11, maybe 12 o'clock before your rush hour starts. All right, next one. This graph doesn't have any grid on it, so we have to estimate a lot. So if you rented 5 games, how much would it cost? So all you have to do is look at your axis again. So your total cost is up here, so I want to know the answer from that column, but the number of games is on the bottom. So if I rented 5 of them, here they go. There's my point. How much would it cost? So that's about halfway right in between $20 and $40 there, so that must have been $30. How many games could you rent for 60 bucks? So now I want to look on this axis, 60 bucks, and see how that lines up. So there's my point that I'm looking at, so that would have been 20 games. All right, now this is an estimation one. About how much would 12 games, sorry, there's a typo, would 12 games cost you? So I have 10, I have 15, but I don't have 12. So we're probably about 12.5 there, so we're probably about right here, and we have to estimate where that is. So we were at 40 recently, I think, and then looks like 50 is at 15. So if that's 50 right there, how much is about for 12 right there? And I'm going to estimate at about 44. Now you might estimate a little bit differently. You might even be able to find an exact value, because I know the original amount just for one game would be 20, and then by 5 is 10 more, so I'm estimating they're $2 each at this point after your first game. So what do you think 35 games would cost to rent? So this one I'm having a little trouble here because I don't have 35 games, but let's see how much it's going up. So every 5 down here, it goes up, how many? $10. So at 25, I'm at $70. So if I go to 30, I should be 10 more than that at 80. And if I go to 35, 5 more down here, then I should be up at 85 up here. So it should be about $85 to rent 35 games. Now I don't know what you're doing with 35 games, but that's about how much it would cost you to rent it. And let me go back real quick. 35 games, I think we might have estimated that wrong. I'm sorry, that should have been 90, because we're going up 10 this way, 5 this way. So we're going 5 this way, but 10 that way. So if you notice, I'm pulling out my rate of change, which is my slope when I do this. So I know I should have been counting by tens on the x-axis. So that should have been 90 right there. Sorry about that. We all make mistakes. All right.